Hi, this is Malathi, currently working as an assistant professor in the Department of Computer Applications PG in Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. In this video, we are going to see about the topic representation learning. It is a part of the topic which comes from machine learning. In the previous videos, we have seen a clear explanation about what is machine learning, and under that we had seen the types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. What is representation learning? Representation learning is a part of machine learning which is used to dedicate and identifying and creating the efficient representation of data. We can gain a deeper understanding of complex data structure. It is very essential for the better performance of a model, and it includes the classification and clustering. What is basic representation learning? Representation learning which identifies and extracts the feature from raw data. For example, if you are going to develop a model to predict some results, we need to insert the data for the machine to learn the machine. So for that, if it is a supervised learning, we insert the data which is labeled one. If it is an unsupervised learning, we will not label the parts. The machine not able to identify it accurately. It matches all the features and it predicts the results. So like that, if we are insert the raw data, using the raw data, the representation learning, according to the feature, it can predict the results what we expect and why we have created for the model. The importance of using representation learning: it enhances the model performance and it is used to do the various tasks. It includes supervised, unsupervised, and semi-supervised learning. Supervised, I have explained already. Supervised is a model which we insert the data of labeled one to the model. Unsupervised is we will not label the objects and we will not label the data while we train that model. Semi-supervised is it is a partition of supervised and unsupervised. What are the techniques we used in representation learning? The techniques are autoencoders, deep learning, and word embeddings. Autoencoding, it is a unsupervised neural network which is used to learn to compress data into a lower dimensional representation. We had already seen about the two-dimensional and three-dimensional representation. It is maximum uses in the audio and video format files, and it captures the essential features in the process. Deep neural networks automatically learn hierarchical levels of representation, where lower layers capture basic features and the higher layer captures more complex pattern. In every model, it predicts the results using and analyzing through the patterns. So that's if it is a lower one, it captures the basic features. If it is a higher one, it captures the complex features. And the word embeddings, like Word2Vec and some other software, it is used to convert word into continuous vector space representation, and it's also the capturing semantic relationship which had a relationship between the words based on their usage in the context. Next, we are going to see about the applications of representation learning. Mostly we are using these kind of representation learning in various fields such as image recognition, natural language processing, and recommendation system. Image recognition method in the real world itself we have so many models which is related to the image recognition method. In that models we particularly using this type of representation learning to train the model, and natural language processing models also we are particularly using this representation learning. And the recommendation systems also is used to enhance the performance in various platforms such as commerce platforms and streaming services. We are using this representation learning to train the model to predict the correct result. And what are the challenges we are facing in representation learning? Of course, if there is a pros and automatically it will have a cons too. So overfitting of data is also a challenge which is faced while we are training the machine using the representation learning. It may perform poorly or unseen data if the data are overfitting with the machine. And the interpretability is nothing but the understanding how the device specific representations how the device learns about the specific representation. It can be difficult or impeding trust and usability. And the data quality, from the first video I am saying the data quality is very important while concept to train the machine. So this performance of representation learning is highly dependent on the quality of data. If it is a noisy or incomplete data, some optional feature representation may predict the wrong result. And what are the future directions in representation learning? Self-supervised learning, we can integrate the representation learning with other models, and it is a fairness and ethical considerations. Self-supervised learning, it is a model which is used to learn useful representation from unlabeled data. And the integration with other models, while we integrating this representation learning with other models like reinforcement learning, it can learn the environment and predict the result. And the fairness is addressing the biases and the errors. It is very crucial for ethical AI. It is very crucial for automating feature extraction and enhancing model performance across various domains. It includes numerous techniques and applications. By leveraging these advancements, we can achieve substantial, like it is essential for automation, innovative techniques, and it improves the model performance, and it has some future opportunities too. I hope everyone have a clear understanding about representation learning. Thank you for watching the video.